Hello friends, continuing with type of units. Today we take up derived units in the series of fundamental units, derived units and supplementary units. Now we define derived units. The units of all other physical quantities which can be derived or expressed in terms of fundamental units are called as derived units. For example, speed has a unit of meter per second. So meter is a fundamental unit, second is a fundamental unit. Since speed has unit of meter per second, it means it's a derived units involving two fundamental units, meter and second. Similarly, acceleration has a unit meter per second square. Momentum has a unit kg meter per second. Force has a unit meter per kg meter per second square. For speed, meter per second. For acceleration, meter per second square. For momentum, kg meter per second. And for force, kg meter per second square are the derived units. So I define derived units once again. The units of all other physical quantities which can be derived or expressed in terms of fundamental units are called as derived units. So speed, unit of speed is expressed in terms of fundamental units. Unit of acceleration, momentum and force are also expressed in fundamental units, in terms of fundamental units. So these are derived units. Now we come to supplementary units. What are supplementary units? How we define them? Now units related to angular measurements are termed as supplementary units. Units related to angular measurements are termed as supplementary units. For example, unit of plane angle is radian and unit of solid angle is steradian. So let us define radian and steradian alternately. How is turn by turn? We define radian and steradian turn by turn. So first we take up radian. How we define radian? Let us look at the definition. The angle subtended at the center of a circle by an arc equal in length to the radius of the circle. The angle subtended at the center of a circle by an arc equal in length to the radius of the circle is defined as radian. Now in case of circle, we know theta is equal to L by R. This is theta, this is L, this is R. Okay. In case of circle, we know the relation theta is equal to L by R. Now when L is equal to R, then theta is equal to 1 radian, because R divided by R will become 1. Okay. Now we write here when theta is 2 pi. Okay. When theta is 2 pi means when L is equal to 2 pi R. When L is equal to 2 pi R, then theta will be equal to 2 pi R divided by R is equal to 2 pi radians and is equal to 360 degree. Now we have a relation from here between radian and degrees, that is 2 pi radians is equal to 360 degree or pi radians is equal to 180 degree. Okay. So this is a relation we can use for conversion of degree into radians, because normally angles are given in degrees, minutes and seconds. So we have to convert them into radians. So you can use this relation for conversion. Now consider the relation 2 pi radians is equal to 360 degree. 1 radian is equal to how many degrees? Let us see. Now 1 radian is equal to 360 degree by 2 pi. Simply we use unitary method. So 1 radian is equal to 360 degree by 2 pi, or it is equal to 360 degree by 2 into 22 by 7, or it is equal to 57.27 degree. Now 1 degree is equal to how many radians? Now 1 degree is equal to pi by 180 radians. Also 1 degree is equal to 60 minutes, and 1 minute equal to 60 seconds. Now how much is 1 second in radians? We convert 1 second into radians. So this is 1 second. It is equal to 1 by 60 minutes, and it is equal to 1 by 60 into 60 degrees, or it is equal to 1 by 60 into pi by 180 radians, and it is equal to 4.85 into 10 raised to power minus 6 radians. Okay, so 1 second is equal to 4.85 into 10 raised to power minus 6 radians. So you remember these scales, that is 1 radian is equal to 57.27 degree, 1 degree is equal to pi by 180 radians, or it is equal to 60 minutes, and 1 minute is equal to 60 seconds, because angles are given in degrees, minutes and seconds. So what you do, you convert all the given angle into seconds, and then multiply by 4.85 into 10 raised to power minus 6. It will be converted into radians, because you have to use the radians as the unit of plane angle. So these are conversion scales. Everybody should remember to solve numerical problems. Now we come to steradian. The solid angle subtended at the center of a sphere by that surface of the sphere which is equal in area to the square of the radius. So solid angle d omega is equal to dA by r square. So this is dA, this is r, and this is solid angle subtended at the center of the sphere. Now when dA is equal to r square, then d omega is 1 steradian. When dA is equal to r square, then d omega is equal to 1 steradian. So here you can see when dA becomes equal to r square, then d omega becomes 1 steradian. Okay. Now for practice, an exercise, question number 14. Calculate solid angle subtended at the center of a sphere by its whole surface. So here you solve this problem, you will get the answer as 4 pi steradian. Okay. Now assignment. Assignment 2.1 continued. Question number 15. What are derived units? Illustrate with few examples. Question number 16. What are supplementary units? Illustrate with examples. Question number 17. Define radian. Show that plane angle subtended by the circle at its center is always 2 pi radians. Question number 18. Define solid angle. Show that solid angle subtended at the center of sphere is always 4 pi steradians. So you solve these problems on the basis of the text you have learnt above. Thank you so much. God bless you.